Have you ever gazed up at the night sky, a vast tapestry of glittering stars, and wondered what makes our little planet so special? What is the secret ingredient, the cosmic recipe, that allows for such an astonishing explosion of life? We see oceans teeming with creatures, forests reaching for the sky, and cities humming with human activity. But the truth is, the existence of everything we know and love hangs by a delicate, invisible thread. This thread is not made of matter or energy in the way we might think. It is a thread of distance. The precise, specific distance between our Earth and its star, the Sun. It's a distance that provides the perfect balance, a cosmic sweet spot that has made our world a haven in the vast and often hostile emptiness of space. The story of life on Earth is often compared to a famous children's fairy tale, that of Goldilocks and the Three Bears. Just as Goldilocks found the porridge that was not too hot and not too cold, but just right, our planet exists in a region of space that is just right for life. Astronomers call this the habitable zone, or more poetically, the Goldilocks zone. It's a narrow band of space around a star where the temperature is perfect for liquid water to exist on a planet's surface. And liquid water, as far as we understand it, is the essential solvent for the chemistry of life. Our current position within the Sun's Goldilocks zone is what makes our planet a watery paradise. The average surface temperature of Earth hovers around a comfortable 15 degrees Celsius. Now let's press the imaginary button and propel our planet outwards. As Earth drifts away from the Sun, traveling another 150 million kilometers into the cosmic dark, the most immediate and obvious change would be the appearance of our star in the sky. It would no longer be the brilliant, dazzling orb we know. From our new home at 2 astronomical units, the Sun would appear significantly smaller and alarmingly dimmer. In fact, it would seem only half as wide in our sky. But the reduction in its brightness would be far more dramatic than the reduction in its size. The sunlight reaching our world would be only 1/4 as intense as what we experience today. This isn't a simple guess, it's a consequence of a fundamental principle of physics. Picture the Sun radiating energy in all directions, like an expanding sphere of light. As this sphere gets bigger, the same amount of energy is stretched out over a much larger surface area. This single stark fact is the starting point for a cascade of catastrophic changes that would utterly reshape our planet from the atmosphere down to the deepest oceans. The brilliant daylight we take for granted would be replaced by a perpetual, eerie twilight. This dramatic reduction in solar energy would send global temperatures plummeting. Climate models suggest that without the Sun's current warmth, the Earth's average temperature would quickly fall to a bone-chilling -40 degrees Celsius. For comparison, the coldest temperature ever recorded on Earth, at Vostok Station in Antarctica, was a staggering -89.2 degrees Celsius. Our new global average would be much closer to that extreme than to our current comfortable climate. Such temperatures would make almost the entire planet's surface uninhabitable for humans and most other complex life forms without significant technological assistance. The very concept of temperate or tropical zones would cease to exist. With global temperatures locked in a permanent deep freeze, the most visible and dramatic transformation would be the runaway expansion of ice. The cryosphere would explode in size, eventually encasing the entire globe. The oceans would be the next to succumb. Sea ice would form at the poles and rapidly expand, covering the Arctic and Southern Oceans. This ice would grow thicker and thicker, merging into a single planet-spanning sheet. Our beautiful dynamic blue oceans would be transformed into a solid, static, and silent expanse of white. The familiar coastlines would vanish beneath this global ice sheet, leaving Earth as a smooth white sphere, a snowball Earth. Life in the oceans would face near total extinction. Surface ice would cut off sunlight, shutting down photosynthetic phytoplankton that form the base of the marine food web. The waters below would become dark, cold, and anoxic, devoid of oxygen. The changes wouldn't stop at temperature and ice. The very rhythm of our planet's life, its days and its years, would be fundamentally altered. For Earth, moving to twice its current distance would mean a much longer journey around our star. A year on our new, distant Earth wouldn't be 365 days. It would last approximately 1,032 days, or about 2.8 Earth years. This extended year would lead to seasons of an epic and brutal length. Imagine a winter that is not just colder, but that lasts for the better part of a year. A long, dark, and deepening freeze, followed by an equally long, slow, and feeble thaw in a summer, where the sun still hangs like a dim lamp in the sky. The atmosphere itself would undergo a profound transformation. Cold air is denser and cannot hold as much moisture as warm air. The vibrant, dynamic weather systems we know would grind to a halt. The water cycle would be broken. With the oceans frozen over, there would be no clouds, no rain, and no snow as we know it. The sky would be perpetually, unnervingly clear, except for perhaps a thin haze of ice crystals. What weather would be left would be dominated by wind. These winds would be dry, thin, and utterly relentless, carrying fine particles of ice and dust, endlessly scouring the frozen surface. The sound would be the perpetual, mournful whisper of ghostly winds. Could anything survive this planetary cataclysm? While most life as we know it would perish, the tenacity of biology is something we should never underestimate. On Earth today, we find life in the most extreme environments imaginable. Imagine a world where the only havens for life are deep underground or under kilometers of ice. Geothermal heat, radiating from the Earth's core, would become the new sun. Life could cluster around geological hotspots, volcanic vents, or deep subterranean aquifers. And what of humanity? Our survival would depend entirely on our technology. We would have to retreat into vast, self-sustaining habitats buried deep underground, powered by geothermal and nuclear energy, creating closed-loop ecosystems. This journey to a cold, distant Earth, a world of twilight and ice, brings us back to where we started, but with a renewed sense of awe and appreciation. Our thought experiment, while terrifying, serves a profound purpose. It illuminates the incredible fragility and preciousness of our own world. We are afloat in the vastness of space, not by accident but by a fortunate confluence of physical laws and cosmic history that have placed us in this perfect life-sustaining orbit. When we look at the challenges facing our own planet today, climate change, loss of biodiversity, this cosmic perspective is invaluable. It reminds us that the stability we take for granted is not guaranteed. So, the next time you feel the warmth of the sun on your face, or watch a cloud drift across a bright blue sky, or stand in a summer rain, take a moment, reflect on the 150 million kilometer tether that connects us to our star. We live on a planet that is perfectly placed, perfectly tuned and bursting with life in an otherwise silent and empty corner of the cosmos. Our home is a cosmic masterpiece, a precious jewel of a world, and understanding what it would be like without its gifts is perhaps the best way to truly appreciate them.